Well, good afternoon, everybody. Welcome to Weather School. I'm Chief Meteorologist David Paul here at the KHOU 11 Weather Center. We've been talking we started yesterday talking about how everything is connected in unusual ways when it comes to the planet and science and weather and space. Remember yesterday we talked about how in some cases, most condensation nuclei is actually a specific type of bacteria that lives on plants. It gets up in the sky, it makes its own ice, it encourages rain, so it goes back down, it can eat the plants. Kind of weird. I encourage you to scroll down and find that lesson if you missed it. Yesterday was fun. Today we're going to talk again about how everything is connected in unusual ways you might not at first understand or think is real, but it is. And before we get to this, I do want to give you a quick weather up. We do have some weather coming into our northern counties. Our northern counties are under a tornado watch. Here's the quick setup on the weather. Then we'll get to today's connected lesson. We're going to talk about a bend in space-time. All right, low pressure, you can see it's spinning right there in Oklahoma. That's a surface low. It's dragging a boundary into East Texas that is helping to kick off thunderstorms. That being said, most of the strong storms are north of the Houston area. Now, the yellow area, which includes Brenham, Waller, the Woodlands, Montgomery County, Grimes County, Walker County, all the counties in yellow here are under a tornado watch until, is it 5 o'clock, Addison? At 5 o'clock, Addison Green sitting right here. He's getting ready for the 4 o'clock, and he'll also, if you have a good question, he'll chime in on me. As we look at the actual radar, you can see that even though this area is in a tornado watch, Brenham, Montgomery, Huntsville, there's no action there. And what's near you is lifting northeast away from you. Now, we're watching these scattered showers here off to our west of Brenham, west of College Station. If this area is going to get any severe weather, it will probably be from these if they can tap into the energy of the atmosphere as they move toward Walker County and Washington County and Grimes County and Waller County. So we're keeping an eye on that. We're under a watch, means conditions are, well, some of the ingredients are there, but at the moment we don't have any severe weather warnings here in the immediate southeast Texas area, so that's what we're keeping an eye on. On the 411 at 4 o'clock on the TV side, we'll have a complete update on what's going on up here and what to expect this evening, and it actually is a frontal boundary. Okay, back to weather school. Science. It's all theory. The first rule of science is to admit you know nothing. Start from a place where you know nothing. Here's a perfect example of why we scientists have to start in that place. We know nothing, and then you investigate and you learn, and then you create a theory and you test that theory. So this screen we're looking at here, there's planet Earth, there's outer space. The screen we're looking at, it's a solid, right? It's hard as a rock. I can't put my finger through it. It's solid. It's a solid. Who out there can tell me, however, what we've learned about solids through science, what is this solid screen actually mostly made out of? If you get down to the atomic level, what is this screen mostly made of? Does anybody know? Well, it's actually made of mostly empty space. When you get down to the atomic level, you've got an atom, you've got a proton, you've got a neutron, and you've got an electron spinning around that proton and neutron. Tiny little dot, two little dots here, but most of that atom is empty space. So even though this is a solid, I can't put my hand through it, when you get down to the atomic level, it's actually mostly empty space. It's a perfect example of how, upon further investigation, there's a lot we don't know about the materials and what's going on planet Earth and in the universe. There's a whole lot we don't know. That's why we have science, to ask questions and experiment and attempt to find out more and learn more about the intricate, exotic processes that are going on in the universe in which we inhabit. So as we start this lesson about connectivity of different things, this is science, so I'm going to show you some ideas, but none of this is set in stone. These are just ideas as we understand them right now, and certainly down the road, scientists, through investigation and observation and measurement, could find out that these theories that I'm going to present to you are completely wrong, and that's fine. That's the beauty of science. All right, so today's lesson, here's planet Earth. Everything is connected in unusual ways. Okay, remember this, the burger wars. So what do we have here? This is an In-N-Out burger. This is a, well, you can recognize that, right? That's a Whataburger. I recognize that without even seeing the label. So which is better, Whataburger or In-N-Out? I have preference Whataburger, probably because I grew up in Texas. But In-N-Out apparently is pretty good. It's a different experience. But I ask you this scientific question: what is it that you're actually eating when you eat? And let's just stick with the meat right here. What is it that you're actually eating when you eat that piece of hamburger? What is it? My granddad grew up on a farm boy, ended up working for Dole Pineapple in Hawaii as was one of their accountants, and worked on the floor, actually helped to produce the canning process, one of the canning processes that they worked on. But he was kind of a quasi-scientist as well. He would always tease me. When I would visit Granddad in Arizona, we'd go for a hamburger and shake, and I'm like, yay, hamburger! And he's like, oh, you're eating sunshine. And I didn't understand what he meant. I just like, oh, taking a bite of sunshine as a little kid. I was like, oh, that's fun. Then as I got older, I thought about that a little bit more. And that's where this lesson comes from. This, I would argue, and I will prove to you, that this hamburger meat is actually sunshine. Everything about that burger is sunshine. It's all based on sunshine. So let's talk more about this hamburger. So when you take a bite of hamburger, you can say, no, it's not a hamburger, that's sunshine. So where does hamburger come from? Okay, it's cow. It's ground up beef. Grind it up when we cook it. It's this cow is concentrated sunshine. It's energy. We get energy from that hamburger, the food we eat, and then we can run around and play with that energy. Where does the cow get its energy to become a cow, to grow? Well, cows are famous for eating grass. Here's a cow eating grass. The grass goes into the cow. The cow's metabolic processes turn it into a bigger and bigger cow. And that's how the cow gets its energy. It gets its energy to grow from the grass that it's eating. And here's more grass. Well, what is grass? It has energy in it. The cow is eating the grass to get energy. And that energy that the grass has in it, it's concentrated energy from the sun. Grass uses a process called photosynthesis. It takes sunlight, and with chlorophyll and minerals that it pulls up from its roots from the ground, and combines all of that into sugars. Sugar is energy. It's concentrated sunshine. It's stored energy. So those sugars go into the cow and make it grow, and then you eat the cow as a hamburger, and then you can grow. So the grass is a way of concentrating sunshine. The grass is taking sunshine, using chlorophyll through a process called photosynthesis to make sugars that we can eat. In fact, all plants do that. They use sunshine. So when you eat lettuce or fish or really anything that's alive, plant or animal, you're eating a version of concentrated sunshine. So if we go on that theory, again, all theory, that that's concentrated sunshine, what is it that makes the sun shine? What is the sun? Here it is, that ball of fire in the sky. So what you have going on here in the sun is, it's not a fission reaction, it is a fusion reaction. This is a gigantic fusion reactor. Fusion is a very interesting nuclear process. When a fusion reaction takes place, as long as there is a fuel source, it will give off more energy than it takes to produce that fusion reaction. Maybe you've heard of the dream of cold fusion. So fusion, as we understand it, can only take place under tremendous heat and pressure. So in order to get the sun to do its thing, to create a fusion reaction, and the fusion reaction is very interesting. It gives off one of the byproducts of a fusion reaction is that every time you get a reaction, it gives off a photon of light. And eventually that photon of light travels through outer space and travels to your eye from the sun. That's a byproduct of the fusion reaction. That's why the sun is so bright. It's a gigantic fusion reaction, giving off photons of light, among other things. Well, how does that fusion reaction take place? Why is the sun a gigantic fusion reactor? It's because the sun is so big. In fact, the Earth is about that size to the sun. There's the Earth. That's how big the sun is. The sun is gigantic, much, much, much larger than the Earth. It's so big, it's so heavy, it's so dense, it has so much mass, and mass gives things gravity. And so when something is massive, when it is very heavy and massive, it produces gravity. Actually, all things produce gravity. This phone is producing its own gravity, but it's such a small amount of mass, notice it. But the sun is so large that it creates gravity, and gravity pulls things toward the center. And there's so much force, so much gravitational force taking place that it's pushing all this material together. And when you compress things like that with gravity, they get hot. And that compression, that gravity gets so hot that it finally ignites this fusion reaction. So our sun is a gigantic fusion reactor because of the force of gravity. It is because of gravity that you get a fusion reaction and it gives off light. So when you're eating that hamburger, you're not just eating cow, grass, or sunlight. You're actually eating the result of the force of gravity. So when I got older, I used to tease my granddad. He would say that we'd go for a hamburger and a shake. I'd say, we're going to get a hamburger. He'd say, oh, you're eating sunshine. I'd say, no, Granddad, I'm eating gravity. Because without the force of gravity, there would be no fusion reaction, no grass, no cow, no hamburger, no you eating a hamburger. It's gravity. You're eating the force of gravity, or the product of the force of gravity. One of the elemental forces in the universe, gravity. All right, so the hamburger, you're eating gravity. It's a gravity burger. But then I asked the question of myself, what is gravity? And here's where things really get into the theoretical, although these theories are widely accepted at the moment. And most of them come from this guy, from Albert Einstein. This guy. So he had a very interesting theory about gravity. What is gravity? When you toss that up and it comes down, is something pulling on it? Is it physically being pulled down by strings? What is it? Well, it's a tough one to explain, but this guy came up with a theory, and it has to do with general relativity and special relativity. And we don't have to get into all of that. But what he did was he made it kind of simple for us to understand. He took a 3D concept of space-time and squished it down into a 2D plane. So this is a 3D concept in a two-dimensional plane. And notice how in this case it's planet Earth. Here's planet Earth. This is why we have gravity. We feel this pull down. As far as we understand, it's not as if there are strings pulling down objects. There's no strings pulling me down to the ground. What's happening is this massive planet that we live on, this mass, this heavy, heavy mass, again, things that are massive, things that have mass create gravity. The planet's so big it creates gravity. Why does it create gravity? It is as if it is bending space-time. See how this is represented? It's kind of bent down. It's like if you had a trampoline and you put a bowling on that trampoline, it would sink down that flat surface and everything would roll down toward the bowling ball. Well, think of the planet Earth as a bowling ball, and it bends. Again, this is theory, but it's widely accepted. It's bending space-time so that there's nothing pulling down on me. It's just that this is how we're flowing downhill. Everything flows downhill toward the heavy object, be it the sun or planet Earth. this is an oversimplification of the force of gravity, and there are other theories out there, but this is at the moment the most widely accepted one, that it is indeed a bend in space-time. Somehow that force, that heavy object, the Earth or the Sun, is bending the fabric of space, and things roll downhill. So it's rolling under its own weight. Things roll or are attracted to that heavy object. So that hamburger that you're eating, the burger wars, are all a product of a bend in space-time that produces gravity, that ignites a fusion reaction, that gives off sunlight, that feeds the grass, that feeds the cow, that feeds you when you go to In-N-Out Burger or you go to Whataburger. So next time someone asks you, hey, you want to get a hamburger? You can say, no, no, no. I want to have a bend in space-time burger. Because that, in theory, is what you're eating. All right. Anybody got a question or a shout out for me, Addison?
Yes, Dave. We got a shout out from Star Miller.
Hey, Star Miller. How are you guys doing?
Jason Miller are watching. They said this is awesome. We love this.
Hey, Jason Miller. Nice to see you guys today.
We got another shout out from Jonathan Garcia and one of our top fans, Misha Hawkins.
Hey, Misha. Hey, Jonathan. Nice to see you guys.
And we have a question for you.
Okay, a question.
Preston asks, how does all this physics and gravity stuff connect to how the weather works?
Well, that's a great question. How does all this physics and gravity stuff react to how the weather works? Very good question. Well, let's just start with gravity. If it weren't for gravity, the bend in space-time causing things to roll downhill toward heavy objects, toward planet Earth, if it weren't for gravity, the raindrops wouldn't fall down to the ground and go into the ditches and creeks and rivers and streams. So gravity is it would be an understatement to say gravity is a very, very important elemental force. It is because of gravity that my body is being held together at all. Gravity holds things together. So I think the best answer is gravity makes things like clouds and rain fall to the ground. In fact, it is gravity that is holding the oxygen that we're breathing. It's holding it on the surface of the planet. Gravity is pulling it down toward the center of the Earth. It is gravity that allows life on Earth to exist. And any other questions?
No more other questions. So 2 more shouts from Angie Fox and Melissa Malloy.
Hello, Angie. Hello, Melissa. Thanks for joining me today. Okay, so great. So this has been lesson number 2 on how things are strangely connected together. That hamburger, it's not a hamburger. It's a bend in space-time burger. It's the result of a bend in space-time. So tomorrow is interesting. I'm either going to talk about, I want to do a lesson on the Doppler and Doppler radar, on the Doppler effect. We could talk about that. But I think I'm going to do tomorrow another weird thing about how the planet is connected. We're going to talk about how Saharan dust creates algae blooms and a carbon dioxide sink in the Bahamas. Let's talk about that. It's very unusual. I'll talk about how they discovered this and how that dust also impacts our weather here, especially when it comes to tropical development and hurricanes. Yeah, let's do Saharan dust tomorrow and how it's connected. Even though it's 5,000 miles away, that dust impacts our weather right here in Houston. All right, signing off for Weather School for today. At 4 o'clock on the TV side, not only the latest update on what's going on, but also we're tracking severe weather to our north. We'll have an update there at 4 o'clock. We'll see you then.